Problem 11. First, we calculate the total weight of them to be seated. And because there are 6 people and we can choose any of them to sit in the first seat, and then we can choose any of the rest to sit in the second seat. So the total ways of seating them will be 6 factorial. And then for Abby and Bridget to sit in the same row, there are 2 ways. If Abby sits first, it can be ABX or XAB. So that's 2 ways for them to sit in the first row because we can switch their order. So we multiply 2, and because there are 2 rows, we can multiply 2 again, and that's 8 total ways. And because the rest 4 people have 4 factorial ways to sit in the rest 4 seats, so the total number of combinations for A and B to be the same row would be 8 multiplied 4 factorial. And for them to sit in the same column, we can have A sit on top, B sit on the bottom, and there are 3 ways of doing this. And because they can switch for B on the top, A on the bottom, and that's 2 more ways, we multiply 2, and then again after they are seated, there are 4 factorial ways for the rest 4 people to sit. So that means for them to sit in the same column, there are 6 multiplied 4 factorial ways to sit. So the total probability would be R plus C divided T. That equals 8 multiplied 4 factorial plus 6 multiplied 4 factorial divide 6 factorial. We can cancel the 4 factorial on top and bottom, and that becomes 8 plus 6 divide 5 multiply 6, and that equals 7 over 15. Problem 12. From 12 o'clock noon to 7 o'clock, the car clock ran 7 hours. And because for every 35 minutes the car clock ran, the watch would run 30 minutes. And so we use 7 to multiply this, and then we get that's 6 hours. So the watch should be 6 o'clock. Because the 4 test was an integer between 0 and 100, we can assume the score is x, and the last test, the score is y. Therefore, we will have 4x plus y equals 5 multiply 82. Because there are only 2 values, x and y, so we can easily see that x has to be less than the average value, and y has to be larger than the average value. And by how much we can manipulate this expression to be 4 y subtract 82, and then on the right side we have 4 multiply 82 subtract 4x, and we can further write this to be y subtract 82 divide 4 equals 82 subtract x. Now it becomes that y subtract 82 divide 4, it has to be an integer because that's where each x is different from the 82. So if this has to be an integer and y is larger than 82, then y can be 88, 92, if this has to be an integer, then y subtract 82 should be divisible by 4, and the first value should be y equals 86, and then 90, 94, 98. So that's 4 values in total. Let's first calculate the prime factors of 120 for this problem. 120 equals 2 to the power of 3 multiply 3 multiply 5. And for the 5-digit number to be the greatest, we can say that 2 to the power of 3 is 8. And 8 is also a factor of 120. And because 9 is not a factor of 120, so 8 is the largest single-digit factor of 120. So we should put 8 first in a 5-digit number, and then it should be 5, 3, and we can fill the other 2 digits with 1. So their product is still 120. And so this is the number we are looking at. Now what's the sum? It's 8 plus 5 plus 3 plus 1 plus 1 equals 18. Problem 15. Let's assume the radius of the small circle is r. Because the two small circles area is 1, that means 2 pi r squared equals 1 for the small circles. That means r squared equals 1 over 2 pi. Now for the large circle, the area equals pi. The large circle's radius is 2r squared, and that equals 4 pi r squared. Because we have r squared equals 1 over 2 pi, so we can substitute that into here. And that means the large circle's area equals 4 pi multiply 1 over 2 pi. It equals 2. So the shaded area will be the large circle subtract the small circles. That's 2 subtract 1 equals 1.